About the base and transport layer. Almost everything was already introduced this morning, so it's going to be very, very, very quick. Have you visited the Lightning repo on GitHub? Who hasn't? Okay, good. So you've seen all this. That was a test. So we've covered almost everything this morning. I'm just going to get back to the base protocol, Bolt 8, and maybe Bolt 9, because I don't think it's been mentioned a lot. So basically, this is the kind of communication we have in Lightning. So you have a transport layer that encrypts and authenticates messages, and then you have a base layer that describes what kind of messages you actually use. And the two can be cleanly separated. The base protocol this has been shown this morning, so I'm going to be very quick. It's a custom binary format. The max size of a message is 65 kilobytes, and basically you have a type, 2 bytes, that tells you what kind of message you're dealing with, and a payload. And the payload depends on the type. The old messages, and the one we use today, use custom encoding, which is a bit hard to extend. And the new messages that are going to be introduced, hopefully within the next few weeks, use TLV encoding, which is much nicer to play with and extend. I'll explain what TLV means just now. TLV encoding, it's a generic type length value encoding that you find in a lot of protocols. It's something that you find in ASN1, for example. Who knows what ASN1 means? Okay, you're very lucky. It says ASN1. It's something that is used in yes. It's ugly as hell, but it's an example of TLV. TLV record means you have a type. In our case, it's going to be a Bitcoin variant, a length, again a Bitcoin variant, and a value. It could be anything, and it depends on the type. And you have TLV streams that are just a bunch of TLV records all put together. And in Lightning, we added additional rules, like records are sorted by type, and you can use a specific type only once in TLV stream. The good thing about TLV encoding is, even if you don't understand a specific field, you can skip it. You can just read its length and skip over the field. It's not possible with the messages we have currently in Lightning, so if you don't know how to decode them, you're stuck. Probably, yes. So the transport layer, it's been described this morning. It's based on noise. Each node has a unique private public key pair. The node ID is your public key. There's a handshake phase in noise, so you authenticate the node you're trying to talk to is actually the node that knows the private key of the public key it's using as an ID. And once you've performed the handshake, once you've checked that you're talking to who you really want to talk to, then you derive encryption keys, one for inbound traffic, the other one for outbound traffic, and then everything is encrypted using these encryption keys, which will be rotated every 500 messages. The transport layer is in charge of handshake. You really check that you're talking to the node you're supposed to talk to, and then you decrypt packets that you pass to the application layer. So that's it for the transport layer. So I told you it would be quick. Do you have any questions?
Why 500? Why 500? I mean, how was this number chosen?
Because we want to rotate keys every 500 messages, and keys are used twice for every message. So the keys are rotated every 500 messages. You use the keys to decrypt the length and then to decrypt the value.
Yeah, no, but why 500? Why not 200? Why not 5,000? I mean, okay.
I don't think there's a specific reason for that. You want to change the keys too often, and I guess 1,000 is...
I don't think there's any reasons to specific amount. We just want to, like, there's the But there's the birthday attack, so the amount of nonces divided by 2, and then just every couple of something that sounds reasonable for the protocol. Like if your protocol sends thousands of messages every second, you won't want every 500. If your protocol sends one message per second, you want every less.
But
I don't think there's any.
one cool thing you can do with Lightning is you could basically isolate this and have your implementation work with plain text messages and build a front that is in charge of encrypting and authenticating messages that is separate from the rest of the application. It's something we're thinking about right now.
I would actually really like that because I'm running the integration tests and they're hell to debug.
Yes.
With the encryption layer intact.
So it's the key exchange here, is that also Diffie-Hellman?
Yes.
Yeah.
Yes.
So we use Diffie-Hellman here and also Diffie-Hellman in the HDLC.
Yes, for completely different reasons, but the handshake phase in noise uses Diffie-Hellman.
And then every 500 messages, you also go through the same process.
You rotate keys. You basically increment an index, and you have new keys.
Is that like HD keys?
No, it's not.
Just rotate,
Yeah,
kind of.
No, it doesn't look like a BIP32 derivation. It's something else.
It's the Char poly that Christian mentioned. So it's basically this random generator that is XORed with your messages. And the random generator has a certain seed value, and this is just increased basically. And this creates a new pseudo-random string. That's why it's also important to know that it's every 500 messages, because both parties have to exchange keys at the same time.
If you have an off-by-one error in your implementation, you won't be able to understand the traffic after the first key rotation.
Could that happen off by one?
It did happen, I think, the first few weeks, but not anymore.
So there's no handshake to say, hey, we changing key now. We just change it.
Yeah.
Interesting. Okay.
Something that was mentioned this morning also is a payment request we use in Lightning. So basically, it's a way of encoding payment details like hash, amount, and expiry. You can add metadata like a description of what you are actually buying, and you can add routing hints. That is, suppose your channels are all private. It's impossible to reach you because nobody will see your channels in the public routing table. So you can add hints that say, okay, use a channel I have to a node that is in the public routing table to get to you. This is what we use on Eclair. I don't know if some of you use the Eclair wallet, the mobile wallet we developed, but all the channels it creates are private. So you won't see them on Explorers. So if you want to receive money, there is no way to find you. So we use routing hints in a payment request you generate when you want to receive money to make sure that you can be reached. This is also very useful if you're a merchant and you don't want for some reason to publicly announce your node because you're a terminal node. You will not be routing payments. You're like the end of the way. All you get is incoming payments, not outgoing ones. It doesn't make sense to make your node public. It's useless from a routing point of view. So you will also use routing hints to receive payments. And there's something that was mentioned really, really quickly this morning, but not a lot. It's the how we assign and use features in Lightning. So this is about to change, but right now we have what we call local features. Features that are local to the channel you have with your direct peers, and global features that are global to the network. And for example, that you would need to know about if you wanted to use nodes that have certain properties. Like suppose we change the onion format, and not all nodes support the new onion format. Then you would need to select nodes that you know will understand the new onion packet. There are no global features assigned yet.
We're about to sign.
Yeah. So the local features that are defined today in Lightning are data loss protect. So when you reconnect to your peer after you've been disconnected, you exchange what we call channel reestablished messages, and they tell you, okay, the last point I have is this one. The last secret you send me is this one. If you've fallen behind, for example, if you have lost data, your disk crashed, and you're using an old backup, it's very risky to keep on going because you will probably publish an old state and use your money. So if the node you're connected to is nice and supports that data loss protect option, they will give you the points that you need to spend your output from the transaction that they will publish. So it is something that is called, I think, by LND static channel backups, but it's not really backups because you still need the other guy to do something for you. The data you have locally is not enough. You need the peer you're connected to publish their current commitment transaction, and then with the information they gave you, you have enough to spend your remote outputs. You have enough to recompute the key that the two remote outputs sends money to.
What is if they lie? If they don't send you the current state but an older state?
Yeah, but you can't know that you don't.
Well, they don't know that.
Basically,
They don't send you a stage.
first, so it's something that is supposed to be a last resort. If
Sure.
you've lost data, you have no money, so it's like an extra chance to get it back. But for your, suppose you lie and you say, okay, the last point I remember is an old one, and you basically you haven't lost data. It's very risky for the peer you're connected to try to cheat, because maybe you have not lost your data, and if they do that, they will lose everything. So it's a way of making sure that you can get your money back if you've lost everything. Basically, to get this to work, you need a very limited amount of data that you can know once you've created the channel. The second option is initial routing sync. It's what Christian said this morning. Basically, it says, send me everything, all the routing information you have. It's not used anymore because the routing information is just too big.
So when I set up like a Redshift local Lightning cluster, I always wondered why it takes so long for the channels to propagate. Is it related to that?
No, it's because you need to generate blocks.
Right, I do that for Redshift, my script generates.
Then your node will be notified that new blocks have been generated with typically, I think everyone is using the ZMQ notifications.
No.
What are you using?
We poll for blocks.
Okay, but whether it's polling or using ZMQ notifications, it's not really instant. It takes a few seconds before you get the notifications.
So even in that case, due to denial of service concerns, we implement what's called a staggered broadcast. So we queue up changes in our local buffer, deduplicating them, and only after a minute or so we flush them to our own peers. So that means that I can bombard you with channel updates because, well, you can actually do that. But since I buffer them locally and deduplicate, only the last one will actually reach beyond me as to the rest of the network. So that's how we throttle your broadcasts in the network. But that also means that your update will actually be delayed by the diameter times 1 minute. And so that may be the case there.
So your tests take probably take a while to run.
I've seen it as well, yeah.
So what we have is in the def mode for C-Lighting, for example, we simply set this staggering mode to a second or so, and then it only takes like diameter number of seconds.
The user can't do that.
Well, if you compile it with developer equals 1,
Cool.
you can do.
Cool.
And I think it's actually by default that we enable that.
So the next option that is defined is upfront shutdown script. Basically what it says is as soon as you open a channel, you're going to tell your peer what public key script to use for the final closing transaction. It's an option that is useful because suppose your node gets compromised and someone takes control of it. To steal your money is very easy. You say close the channel and send everything to the hijacker's address. If you use this option, what it means is even if somebody takes control of your node and makes it initiate a closing transaction, that closing transaction would send money to a public key script that was defined when you see that control of your node, and that is supposed to be much harder for the attackers to steal funds from. And the last option is gossip queries. It says more sophisticated gossip control. It is still pretty basic, but basically it's a few queries that I think it's going to be explained in details some more. That's you can use to synchronize your routing table much more efficiently than just send me everything. And this is something for which there's an open pull request to extend it further with timestamps and checksums. But basically it's a way to very quickly get the information that you're missing so that you can start finding path for payments very quickly when you start. And that's the last item today.